Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about optical motor soft encoder. So this is the concept that will be used to measure the speed or position of that particular motor soft. So this will be interfaced with the 805 microcontroller to measure a position of that motor or a speed of that particular motor. Both can be measured by using these mechanisms. Look at this interface. So this is the optical encoder. Look at this. We have two things. One side this is a transistor and another this is we have an LEDs. So once the LED is turned on, so this LED will be fall on this transistor base. So this transistor will be turned on. So by using it we get a signals. Look at this. This is an encoder wheel. Look at this. We have so many openings. So this is like a pulse. So what happens if you rotate for a single time? What happens each time? So this will be interface. So here it will be connected. So what happens whenever the LED and photon transistor will be coincident with this opening? What happens? The pulse will be passed. So what happens for each rotation? How many openings available? That much of pulse we can get it. For example, if we have a 24 openings. So each rotation I get 24 pulses. By counting the pulses, I can get a speed or a motor position and soft. Look at this how it will be interfaced. Look at this. So this is the wheel and that will be connected. Look at this. This is the motor. Rotor will be connected to here this soft encoder wheel and this position that is optical encoder is fixed above this. What happens? So for example, if the wheel is rotates, so for each rotation, each opening that pulse will be counted. So for example, if we have a 24 openings, 24 holes in this shaft, so each rotation I get 24 pulses. So based on that I can measure it for a speed like an RPM revolution per minute or a RPS revolution per second. Everything can be measured depending upon that requirement. Again optical positions also can be measured by using this. For example, how many pulse? So a beginning pulse or a 10th pulse or a 20 or a mid positions each will be measured by using these positions. Look at this how it will be interfaced. Look at this. This is the actual soft encoder. So we have the circular windows. Look at this same thing. So here we have an encoder wheel. No. So here we have a square opening. So here we have a round opening. That's the only difference. Look at this. So here this will be connected to the motor rotor part. So once the motor rotates, so this disc will start rotating. So this disc contains the holes. Look at this. So it may contains a required amount of holes. So we take a default sizes like a 24 or a 48 or like that. So depending upon that, even we take a 60 pulses. So what happens? So for example, if we have a 60 holes here, each rotation I get 60 pulses. For example, if we have a 30 holes, what happens? Each rotation I can get a 30 pulses. So this will be useful for making a speed or measuring a speed or positions. Look at this how it will be interfaced. Look at this. So we have a resistor and that will be connected to LED and that will be connected to the supply voltage. So we have a 5 voltage plus minus. So once if you turn on this, the light will be closed. So here we have a transistor and this will be have a base. There is no connection for base. So this is a phototransistor. So similarly, previous examples we have seen the phototransistor. Once if the LED light falls on this base of this transistor, what happens? It gets pulse. How it gets pulse? So this transistor will be turned on. Once this transistor is on, the output becomes 0. Once if the light is not false, because we have a different position, no? So what happens? So the transistor becomes off. Once the transistor is off, the output becomes 1. How means? See, look at this is off. The VCC is connected to output. So output will be high. So if the disc rotates, what happens? Each time it will be coincident with this LED and transistor base with these holes, we get 1 pulses. So for each rotation, so for example, how many holes available? For each rotation, that much of amount of pulses we can get it. For example, I want to measure a revolution per minute, that is RPM speed. So I need to measure for a 1 minute because revolution per minute. I need to count it how many rotation is completed for 1 minute. So what I do is, so I can take 30 holes. Or we can take a 60 holes, both will be okay. So for example, if we take a 60 holes, I need to measure it for a 1 second. So 1 second if you measure it, so I get 60 into that much of rotations. So why I am taking 60 holes means, so I need to measure it for 60 seconds. So then only it will be 1 minute. Instead of that, I can measure it with a 1 second. So what happens? So with this RPS, I can convert for an RPM also. So how much amount the speed? Very simple. So I need to find it for, if you want this in RPM, revolution per minute. I need to find it how many rotation is completed in 1 minute. So if you have 1 holes, so what happens? Each rotation I get only 1 pulses. If you have 2 holes, each rotation I can get a 2 pulses only. So how many pulses get the result divided by number of holes. So that will be number of rotations per minute. So we need to do it for a 1 minute. Thank you.